Hello, this is Jonathan Blansett. I'm doing coding problem 2.3 of the bisection. It is of the same flavor as 2.2, only a little more efficient. Okay, this is all in the same file, so I'm pretty much just going to use a good bit of this 2.2 that I have here. And I'll edit some of it, take some of it out. So we don't need this. Okay, instead of just having a general true statement here, we're actually going to test this against a threshold balance, an epsilon balance. We're going to need to define that here. This basically gives us a threshold tolerance of 1 cent so that we know that we are charging the customer exactly what they're to the penny. We're going to have to establish our upper and lower bounds as well. And lower bound is just going to be, of course, what the balance would be if it was just like up here. If you just took it and divided the rate by 12 months, or the balance by 12 months, and there was no interest. So that would be the bare minimum, in other words. And so that would be the balance. Then our upper bound is going to be the defined right here. Let's see. Yeah, that's going to be that right there. Balance times. Of course, this will be times our monthly interest rate. I do believe that that is. Okay, let's look and see. Okay, that's to the 12th power. I got you. All right, and the true bisect. I'm going to test the upper and lower bounds. So basically, we're going to subtract the lower bound from the upper bound and test it against our threshold value of epsilon. That way we'll iterate through and see if we've found the most accurate payment we can. Basically, we're just resetting our balance to the original value here, so we can always have a copy of the original balance. It's always good to do when you're working with monetary figures. So it's a percussion. So we're basically going to make our payment, fixed payment. I'm going to add the upper and the lower bounds together and basically bisect them, divide them by 2. Then that way we'll get an average each time. And whenever it gets within our threshold, the epsilon, it'll kick us out of the while loop and we can display our info. That's just the clip I just took from earlier and repasted it back.
And then we're going to simulate the 12-month cycle.
Alright, just like the last program of this nature, we had to iterate through with a while loop because we weren't sure how many times. We'll have to do the same with this one. Use a nested for loop. And again, another if statement. And as I was looking through this code and typing it, I realized shortly after I typed it that it was identical to the code above. Alright, in our if statement here, we're going to test to see if our lower bounds and upper bounds are correct. If we're greater than 0, it's too low, so then we need to adjust the lower bounds. We'll set it equal to the fixed payment, and if it's less than 0, then our payment was too high and we're paying it off too quickly. So we'll adjust it accordingly and set that upper bound equal to our fixed payment. Here I realized I needed to go ahead and copy my former print statement since it's going to be very similar, and I'll just insert it into this other program. Now that I'm looking at this, it looks like my if statement's got a bad indentation. We'll see when we run it though. Alright, looks like we got some problems. We can fix. No, that don't look right. Looking at, let's fix that spelling error. I still think that this if statement's not letting me exit out of this while loop. So let's fix this if statement. And it looks like that got it. Yeah. Again, indentation is key.